Good afternoon, everyone, and I hope I'll be able to keep you awake for next 15 minutes after lunch, after prize distribution or all the distribution. It is the time for fun. So, all right. So I'll be talking about EDA or event-driven architecture, or to be very frankly thinking. Or frankly talking about it, we like to talk about event-driven thinking rather than event-driven architecture. Because without thinking the way you design your application, it is very difficult for you to actually design it, right? So, so if you're thinking in a more synchronous way, you won't be able to define your application in an event-driven way. So, can I have that? Okay, sorry. All right. So before we jump onto this, Can I ask you to raise your hand if you have traded on any of this stock exchange? Or if you have recharged your phone on any of these telcos? Did your banking on any of these banks? And I know there are no Indian banks, but that is probably because we are not allowed to use logo, not that we do not have customers. And you have traveled to any of these regions. So if you have raised your hand at any of these instances, you have already experienced the real-time integration or real-time data availability or real-time streaming using Solace. So the whole idea of showing this slide is not to showcase our logos, which definitely our marketing would like to love. But my idea is that the event-driven architecture is not as niche as you might be thinking of. It is very popular, very mainstream now. So most of these organizations have already moved on to use event-driven architecture. And okay, so coming back to our digital banking or banking in general, the challenges that has been faced by most of the bank is the lower transaction cost, higher reliability, even higher load because of the micropayments and digital payment, which is ever increasing after pandemic. The customer expectation. So the expectation of customer is always that they want all their data in real time available to them. So basically, they want to have better insight of their uses of banking or insurance or any other kind of financial transactions that they're doing. So all these things are putting more and more pressure on banks and their digital platforms, which is basically forcing them to think event-driven. So again, going back to event-driven architecture, they have to start thinking in the event-driven way. So every transaction, when it initiates, who all will need that data, which all application would need that data is more important. So if they're not thinking event-driven way, this is something that they end up doing. So request reply or synchronous. So basically, application needing the data or a particular type of data will be polling. And the more and more polling puts pressure on both the requesting application as well as the responding application. So you need more compute. The time of polling will reduce significantly, and you end up putting a lot of compute in the applications. So giving you a real-world example. So we all use Twitter, or at least heard about Twitter in some way. So how Twitter works? So Twitter basically, every user can publish their thought or piece of information and then attach a hashtag along with it. So basically, every tweet will have an hashtag. So I mean, every Monday, I subscribe to hashtag like vegan, workout, hard work, all that stuff. But then over a period of time, every Friday, my subscription changes to party, pubs, and all. So again, same user, same application, changing it. Similarly, the other users will change their subscription according to their requirement. So this is the real-time use case. We are living in this world where we use Twitter or see users using Twitter. Now just think of it applied to the enterprise. So now Now think of the enterprise doing the same thing where you have a piece of information which is called events. So every transaction in a bank, be it an account opening or a payment or a notification, OTP notification, everything is an event. Now all you have to do is publish this event on a topic. Just like you do a tweet on a hashtag, you publish event on a topic, and that topic will be subscribed by n number of applications you don't need to worry about. It's the subscribing application which need to know which type of data they are looking at. So when we talk about topics, I thought it will be easier if I take a minute of you to explain what the topic, the events and the topics are. So events can be anything. I mean, any piece of information on which somebody wants to take an action can be an event. So for example, let's say on this hall, there is a door, emergency door. Whenever it opens, there is an intimation that need to go to an emergency service provider like firefighters or a police or something. Now, one option is that all these systems of firefighting department and police department keep on polling that door, which is probably going to be opened once in a year, but then they keep on running that applications 24/7, 365 days just for 1 second use, which is going to happen once in a year, which is going to be complete waste of resources. Another option is you make this whole thing event-driven. So when the event opens, when the door opens, the events get generated, and that events will be distributed to whoever needs it or whoever has subscribed to it. Now, so that's an event. So how do you define an event? So event is a piece of information. Again, it can contain a payload, the payload is basically can have any kind of business data. But then more important thing is the event should have some kind of address. Just like on envelope, when you put a letter in the envelope, you put an address on top of it. So that address to the event is topic. Topic basically can be defined in multiple, in a standard structure, which is like noun, verb, and the metadata. So noun is an object, like what object you are sending. So for example, a publisher is publishing an event which is a payment type. So basically payment, it will initiate. So a verb is initiate, the payment is initiating, and then there is a complete information of what type of payment it is. So it's an payment in India, version 1, it's a UPI payment, and you can have n number of details in the metadata. When publisher is publishing this event, your subscriber can subscribe. So each subscriber can have their own interest. So one subscriber can subscribe all the payment initiations. So let's say it's a payment processing microservice or a payment processing system. It will subscribe all payment initiations so that it can initiate it. It can process those payments. But there is one application who is just looking at all the UPI transactions for some kind of reporting or analytics purpose. It can just subscribe using wildcard that I'm interested in payment, wildcard, I don't care what type of other stuff is, but then I'll be interested in UPI type of transaction. Similarly, you can extend it to type of notification and account opening or anything of that sort. So basically, this is the publisher is publishing with the event with the metadata, and the subscriber is subscribing the events of their interest using some wildcard so that they don't need to know about each and every metadata of the particular event. So this is what the whole event distribution is all about. So when we get into the more detail of the EDA, what you actually need is a middleware platform which will allow you to distribute these events across multiple environments. So now we all know it's not a data center specific deployment in any bank. So you will have multi-data center, multi-cloud, hybrid cloud, private cloud kind of deployment, and you cannot have one middleware application or middleware broker running in one data center will help you out. So now, to solve that, what you need is event mesh. Event mesh is a fabric which basically connects multiple brokers deployed in multiple environments and give you an integration backbone where you can integrate applications deployed in multiple environments. So you can have a publisher running in your cloud, but then your consumer can be running in a data center. So whole integration between your cloud application to the data center application will be taken care of by the event mesh without you going through a remote call or RPCs or any other technology. So basically, your applications will connect to the local node of the event mesh, and it will start streaming events to anywhere in your environment. So multiple deployment environments in your environment. So that's an event mesh. So event mesh can include multiple hybrid cloud, multiple. It can be a global mesh. So some of the global banks which I was showing in the earlier slide have the global mesh deployed. So you swipe your credit card payment in India, but if your credit card is issued in US, the authorization will be done in US systems, and it is the Solace event mesh which route the events to the respective system, and the response comes back in fraction of seconds. So that's the level of speed, agility that you get with event mesh. Another thing that you need for EDA is the complete visibility to your event infrastructure. So basically, from design to deployment to cataloging of these events so that the different applications can use different events, which topic they need to subscribe, all those capabilities. This visualization is available as part of the event portal, just like we use API portals for visualizing APIs. Event portal will give you the capability of visualizing your designing and visualizing your events. And it will also allow you to generate all these catalogs, organization-wise catalogs, which is basically give you a common marketplace of events. So within the organization, you can have all these events, schemas, applications, who is publishing, what type of events, who is consuming. It will give you the blast radius if there is a change in event, which all applications will be impacted and all. So basically, this will give you complete visibility. This will also give you for brownfield applications where we are not designed to deployment, but you already have some systems running. It allows you to do the discovery as well. So it can basically extract data from your brownfield and then your application and then create a design out of it. Now, couple of customers, I thought it will be easier for you to relate back. So some of the large customers that we have in the banking space who are using it, ANZ in their payment modernization adopted EDA with Solace, and some of the advantage that they achieved was 80% faster event processing, significant reduction in compute and real-time business stats, all those capabilities they were able to achieve. There is a YouTube channel. You can get it from our booth. They'll be able to give you this link, and you can go through the complete video. The ANZ architect is explaining how they actually achieved it. Similarly, the other example I wanted to highlight is the Standard Chartered. They were in the complete bank-wide modernization, where they wanted to move away from point-to-point or orchestration-based integration to the more choreography-based integration, where all the microservices or event-driven microservices will be choreographed on their own. They will consume the events of their interest and then send the response back to the event backbone so that whoever is interested in those events can subscribe them. So this complete modernization is basically being adopted by Standard Chartered. They were able to adopt this and achieve complete EDA along with hybrid cloud adoption. So now their application is deployed across multiple clouds and data center, and they are able to migrate their application between environments without any issue. So before ending, I just wanted to highlight that what some of the industry leaders are talking about event-driven architecture. So in the recent AWS reInvent, they were highlighting that the world is becoming asynchronous, applications are becoming asynchronous, and the event-driven architecture is the way forward. Similarly, if you talk to any of the Gartner analysts, they will also highlight that the way forward for integration is event-driven hybrid cloud deployment. And synchronous integration will remain. I'm not saying that it's going to go away, but then there are some pockets where the synchronous will remain, but then overall integration will be through event-driven architecture or event-based integration. So here I will just rest my case, and if you need more information about customers, use cases, or anything, please feel free to visit our booth, and we'll be happy to discuss with you, explain you what best or how best we can work with you or help you out. Thank you very much.